real close, and you'll see the small hose right there, okay? By the way, y'all know where this is real common, where you see this technology, where it's real common. That's the way an airplane tells how fast it's going, airspeed.
Okay.
Okay? Without one of those, they would have no idea what their airspeed is. Okay? So it's the same technology. If you want to say, hey man, I know a little bit about airplanes now. I can fly. I don't know now. All right. Let's talk about how we hook them up, okay? If we want to measure, number one, just the static pressure, and that's the pressure that is actually pushing against the outside of the duct. You can imagine a balloon, the pressure pushing on the outside of the balloon. That is your static pressure, okay? Well, we would have a hose, and you got to remember, it's not picking up on this part right here, it's picking up on the small hole on the outside, or we could actually have a port on the side of the duct and do the same thing. I've just got it hooked up, so we're using it hooked up too. We would measure that static point off of there, have the hose come over to the meter, and notice this is open to the atmosphere. The other side of is open to the atmosphere. So it's telling me what the pressure on that skin of that duct is. Okay, now if I want to measure velocity pressure, I've got to cancel out my outside pressure. I want to know the velocity of the air that's moving across the point of that pit tuck tube. In that case, I continue to have the static pressure. I may be doing this wrong. Okay, the static pressure is going to have to come around to cancel out. In other words, this is my meter, this is measuring the difference, whereas this one picks up off the point. Now I would be measuring velocity pressure. Can you see how, if I'm measuring the pressure between these two, it's going to give me my velocity because it cancels out the static. Okay? But if I need to know the total pressure, that's these two added together, I would again have this open to the atmosphere, except this time it's going to just measure right straight off of the point here, and it'll give me my pressure of the total pressure. Can y'all see that? I know that's confusing, but that's one of the ways that we can calculate how much air is moving across it. Something to keep in mind. And if you are dealing with, number one, it needs to be a straight section of duct. Number two, if you really want to find out the total, you need to take many different places across the transverse of the duct, because the outside of the duct, the air is not going to move as fast as it is towards the inside of the duct. If you've been on a river before, where's the fastest part of the water in the river? It's in the middle. That's because of the resistance that it has against the banks and all. So it's the same thing with the duct. Go back, it's a fluid, okay? Fluids act the same. All right, now, of course, that's a lot of work, but, you know, what I didn't bring in here was an anemometer. To measure the airflow. I didn't bring one in here, but there's an instrument that we can actually measure how fast, or in feet per minute. And what we would do is we would go across the base of the duct and take several readings. And as we take those readings, there's some that we can actually use to do the average. Electronics will let it do its average without having to do the calculation. Thanks very much.
You're welcome.
Okay. Some of these you can set up so that it will average it for you. Some you would actually have to write each measurement down. In other words, if I were transversing across this duct, I would get my feet per minute with this, take the average feet per minute, add them all together, then divide them by ever how many measurements I had, and then by knowing those two things, I need to know what the square footage of this area is. In this case, I got 1 square foot, so I wouldn't have to do anything. It would be whatever I averaged out here. But if I had a 1.5 foot, or then I'd have to figure that into, okay? That's the way you can check your airflows. That will give you your CFM, okay? That's one way of doing it. Another way of doing it, I have another instrument over here. It's a little bit more sophisticated. I don't have the computer hooked up to it right now, but there's actually a processor, CPU, that goes along with this. I'm going to pass this around, and you'll notice there's 2 pieces in here, one that measures airflow and one that measures temperature. Okay? So what they call a hot wire. And you can pass that around and see what I'm talking about. And by the way, I don't want to rule this one out. You see that little piece right in there? That's measuring the temperature of the air. And that is taken into consideration when it calculates how much the feet per minute is. Okay? Or, if we're measuring a register such as this one right here, we can use what's called a flow hood. Now the flow hood, when you walk into a building with something like this, people think that you're gone nuts. I guarantee you they do. They go, what in the world are you doing? I'm catching butterflies. But this makes life easy, but it's expensive. Okay? And you can set this one up to do, well, it's a computer down here is what it is, so it can do all sorts of things. But I'm going to measure the CFM off of one of the ducts here, or one of the registers coming in. And I'm going to try to get turned like so. Notice how it completely fills up, and what do you see there?
132.
132. Isn't that a whole lot easier than doing all those calculations that we had to do? Okay. But it's expensive. Don't rule out the other way. Well, what's that tell us? We see it reading 132, but what's it tell us? I have 132 cubic feet of air coming through that right now. Being that we're in one room here, in order to be able to balance it out, we would probably want more air towards the outside, or the skin of the building, than we would towards the inside. If we have the dampers and the ductwork, we would adjust it as need be. If we had multiple rooms, then we want all the rooms conditioned evenly, and that's where we would do the test and balance. Okay? The reason it's called test and balance is you test it, and you go back and balance it. Sometimes you have to test and balance more than one time, because when you make a change in one, you're going to make a change in others. And there are some ways that you can avoid doing that and do it in one step. But I have found out that most of the time, I still need to check it at least twice. Okay. We've covered a lot of territory, and in your text on page 1045, it's one good place to look around. Another one is 1061, but it deals with both the psychometric chart and the picto tube also, and some of these other instrumentations. You may think, well, okay, I'm brand new at this. Am I going to need to know this? A lot of technicians don't understand anything about what we're talking about. I go back and ask the question. If you don't know how it's supposed to work, how do you know it's supposed to work? How can you fix something if you don't know what it's supposed to be doing? Air measurements seem to be one of the biggest problems that we have in this industry as far as trouble is concerned. Low airflows can cause coils to freeze up. They can cause the air not to be distributed correctly. High airflows can cause drafts, cause discomfort. If you're in a room and on a cool day especially, if you have too much air moving around you, you're going to feel cool because of the fact that those drafts are going to cause, being that we're humans and we sweat, we're going to have a little bit too high of an evaporation rate created off of us. Even though we may be at the right temperature, it's still gonna feel uncomfortable. So having a set balance is very, very important. Plus, you can actually use a manometer to tell whether a coil stopped up without ever having to open up the duct. Now, I'm not saying a visual inspection is not important, but if you're suspecting that you may have a dirty coil, evaporator coil, you can use one of these to find out before you start slicing into the ductwork or disassembling things. So it is a good tool, but one that has seemed to not be understood entirely, and people are kind of scared of it. You know? Don't be scared of it. Pick it up, try it out, use it. You'll find out that it's a good tool for evaluation of the system. That should conclude us on this.
So all right.